Hi guys, the exams are around the corner, so I thought it would be good to remind you of how to get the calculator to compute derivatives for you. I'm going to show you how to do this first on graph mode and then on run matrix, the standard calculator mode. I'm going to be using a CASIO FX CG10, 20 or 50. It works the same for any of those. So I'm just going to go to menu and then the section on graphing mode. I've got here a parabola. There is just the parabola x squared moved 1 unit to the right and then 2 units upwards. I'm just gonna draw. By default, you will have this turned off. So what's gonna happen is when you draw a function, go to trace. Remember, when you trace, you can move to the right and to the left, and it will show you values of x with the corresponding values of y. Well, if you zoom out, you will see that this is indeed a parabola. The parabola you're thinking of. I've just zoomed in to see some interesting parts here. So when you trace, you can move about here, or you can specify a particular value of x. For instance, if I say when x equals 2, it will find the corresponding value of y. If I click execute now, we will just mark that particular point there. But I would like to see also at every given point, not only the x value and the height, the y value, but also the slope, as in the gradient of the tangent line. To do that, I need to go to setup. So I need to go back to where I just went to turn it off. So you click on shift menu. This is exactly where you go when you want to switch between radians and degrees. I always recommend to leave radians by default. Now you go to derivatives and turn it on. Once this is done, you only need to do it once in your life and that's it. Now when you click on draw, every time you trace, you will see an extra number here. That is dy dx. Remember, this is just another notation for y prime or y prime of x, as in the derivative of the function y with respect to the variable x, right? So for instance, in this region, the function is increasing, therefore the derivative must be positive, and indeed, the derivative is positive at all these points. Notice that the vertex of this parabola is at x equals 1. Therefore, at x equals 1 is precisely where the slope should be 0, where the gradient of the tangent line is 0. And indeed, if I just ask for the value of x equals 1, the height is 2, and the derivative at that point is 0. Beautiful. If I move to the left, since the function is decreasing in that region, the derivative is negative. Done. Beautiful. Now, the second way to compute derivatives at a particular point, or even second derivatives at a particular point, is just going to the standard calculator mode. You go to math, the fourth tab, and then here you have first derivative or second derivative. For instance, if I want to compute the first derivative of, say, x squared, and the value x equals 3, I'm going to get 6. Why? Well, the derivative of x squared is 2x. So when you evaluate that function 2x at x equals 3, you just have to do 2 times 3, which is 6. If you want to do the second derivative of, say, the same function, x squared at the value x equals 3, what do you get? 2. Why? Well, the first derivative of x squared is 2x. Therefore, the second derivative of x squared is just the derivative of 2x, which is 2. So the second derivative of x squared is just a constant. So it doesn't matter whether I put an x equals 3 here or an x equals 30, same thing, you're gonna get 2, right? It will matter if I put the 30 here, because you're gonna get 60, as in 2 times 30. But here you go. This is how you get the calculator to compute derivatives for you, both in graphing mode and in standard calculator mode. If you would like me to record some more videos on how to use the calculator just before the exams start, let me know. Write some comments in the comment section below, and I'll see if I have some time to make a video on that. Okay? See you later, guys. Bye.